with Red Hat OpenShift service on Amazon Web Services, AWS. You can take advantage of seamless integration with other AWS cloud-native services and joint support from either Red Hat or AWS.
Here we go. Let's do this. Hi, everybody. Wow, sold out house in here. It's amazing. Welcome to reInvent. This is super exciting. We're like back. It's almost real world again. I mean, I shook hands. I hugged people. I know. Anyway, but I'm Noelle Silver. I'm going to be spending, oh, I don't have to wear my mask. Okay. I'm Noelle Silver, and that sounds a little bit better, a little bit. And you can find out more about me on the LinkedIn. It's a social network. So if you want to find me there, you're absolutely welcome to. I connect with everyone. You never know, as you'll check out with my long history of work I've done, you never know when you'll run into me again. So great opportunity to connect, and I'd love to, of course, help you on this journey we're going to talk about today. I do want to start off a little bit with who I am and how I got here. I've spoken at reInvent, I think, 6 times over the last 10 years. 1 year, I spoke 6 times in one event. But back then, I was an Alexa person. Anyone know Amazon Alexa? I cut my teeth in artificial intelligence there 7 years ago when Alexa was born. I was an early member of that team. I built over 100 apps for Alexa in Java, which is the code language I was born in, but also JavaScript, Python, and then moved into building actual machine learning models, natural language models. I launched 4 language models for Alexa before I was twitching and my family forgot my name, and so I went to Microsoft. And I led Cognitive Services, which was a democratization of AI models. Same thing though, and a problem that I saw consistently in both of these companies trying to do really cool things, build things and make it accessible to everyone, which is really the goal of all of our code, is that it sees the light of day and someone actually uses it. We couldn't really consistently deploy our applications, and we ended up spending time, at the time as a data scientist or even an app dev, I was doing things that were not natively my own, like, preferred skill set, thing that I wanted to do. I was constantly having to take on roles that were not mine. And that was fine, except for the fact that it was a bit of a waste of time because there were other people that could probably do it better, faster, stronger than me. Enter my introduction to OpenShift. How many of you are familiar with OpenShift already? Have used it? All right, good. Representation, nice. So if you hopefully, if you like OpenShift, you'll love what I'm about to show you. But it came from a lot of pain, right? A lot of times in the DevOps world, we end up having to do a lot of connecting, integrating. I used to actually sell the idea of enterprise integration like it was a good thing, but it's painful, right? There's a lot of manual integration that has to happen. And so throughout my career journey, I mean, I've worked at IBM, of course I'm at Red Hat now. At all of these companies, the software deployment process was the same. It was burdened, and it was difficult to scale. So at scale became something that I got very good at. I ended up scaling Alexa from, I think we had 1,000 beta users when I started, to 60 million users when I left. At Microsoft, same thing. I took 17 research projects and scaled them to hundreds of thousands of users. But you can't do that. And it's not just about the container, right? It's not just about the ability to use Kubernetes. It's about all the things. It's about the entire pipeline. And so what I want to do today, hopefully, is show you a little bit about, well, what I've uncovered and what I think is exciting about OpenShift on AWS. So I alluded to this a little bit, but containers, this was actually originally a meme, and maybe you've seen it before. But it's really, originally we thought containers solved a lot of problems. I was the VP of engineering at National Public Radio during a really good time. It was a pandemic from a media company perspective, right? A pandemic was happening, and it was an election year, a crazy election year. So we started to see double the numbers of people coming to our applications, our voice apps, our mobile apps, our websites. massive numbers because of all this craziness that was happening. And then the whole George Floyd thing that happened last summer, like it was craziness, but great for a media company. That's why we do these things. And containers saved the day a little bit, but they didn't solve all of our problems. They didn't solve the fact that we didn't have enough people to do the work of just keeping our sites afloat, of just keeping the wheels turning, and we had a backlog of features we were trying to release at the same time. So unfortunately, what ended up happening is we tabled that backlog, and everyone, all hands on deck, started DevOpsing, right? Started building and focusing on the infrastructure. And that's what we want to do, what we don't want to do, right? We don't want to focus on things that are not our core competency, are not features our customers are looking for us to release as quickly as possible. So what I want to do to demonstrate this a little bit, one thing I'm always looking for is an elaborate demo. I've been in this industry, I don't know, 20-something years now. Hello World, though adorable and trite, is not super sufficient for someone like me who's like, does this actually work? Can I actually use this? So I found a flood disaster response example. And I'm like, awesome, we're going to Vegas with a flood disaster demo. And of course, as you might be thinking, like flood, Vegas, it's not super relatable. Little did I know, you could Google it in July. Anyone here at that time? 1999. I won't make you say that you were here, but there was a flood. 26 active fire rescue missions were attempted and successfully completed. So I'm like, boom, we're doing this. We are actually going to run a flood emergency demo for you. And really it's meant to just kind of give you a little bit of, I guess, complexity to hold the framework of what we're gonna do inside of AWS with OpenShift. So it's an emergency response application that we built. It's 5 tiers. It's a classic cloud native application architecture. And I say classic in the sense of like circa 2020, right? Like we want to build something relatively recent. And any new application you build will often have these things, right? An event streaming service, a way to communicate in real time, 5G, sensor, device communication, edge capability. Now, not all of this is capable right now, but I want to kind of pave a path for you to kind of see what is possible in this infrastructure. All right, so disaster has strikes. We're gonna play this out. This actually is a real scenario that has happened in Hurricane Harvey and Hurricane Katrina. I live in Miami, Florida, so I know hurricanes pretty well. I grew up there. And in this scenario, a volunteer Navy got together and they called themselves, or maybe they were called the Cajun Navy. And they were volunteer rescuers who happened to have boats. Guess what I saw flying into Vegas yesterday? Anyone else look out the window and see? There's actually like a pond with boats in it in the middle of the desert. I don't know why, but they're there. They're like yachts are in this like body of water in the middle of the desert. So good thing, some of you happen to own those boats. So thank you for your service in participating in our volunteer rescue mission that we're about to go on. And then once I show you the application, hopefully you can see it through the lens of a developer or an admin of like, okay, how is this thing working? Then we're gonna break it down, show you what it looks like in Rosa, inside of OpenShift running on AWS. And then at the very end of this session, we're gonna talk about the future and talk about what's next. We always have to talk about what's next, right? It's called job security, and we're grateful for it. All right, let's do this. And of course, if any questions come up, please feel free to like keep them ready. We'll try and reserve about 5 to 10 minutes for questions at the end, but we're also going to be at the welcome reception tonight. So if you want to join us there, you're welcome to do that. All right, so let's take a look. All right, here we go. First, switch. Oh, did you see that? Okay, don't tempt the demo gods. Okay, here we go. So this is an application. It's running on OpenShift. I'm going to sign in as the incident commander. I had the intention of letting everyone in this room become a volunteer and live register with this system and start playing around. For some reason, like AWS as a community thought that would be dangerous. And so anyway, that's Probably not gonna happen, exactly. But I'll show you what it looks like. And I'll also give the ability to build this exact same demo on your own, which is something I always like to do at the end of a reInvent session. I'm like, show me the repo. I wanna go and play around. So you'll get a chance to do that. All right, so here's the dashboard. You can kind of see it. Right now, there is a little simulation section just to identify how many rescue attempts I want to make. You'll also see down here, we're using Mapbox. So I have just a traditional token identified that gives me access to this map information. See the legend there at the bottom, right? It'll show eventually when I start the simulation, which means, there's a flood, emergency has happened. People get the SMS, message from the infrastructure saying, hey, if you need help, let us know through your mobile app, and they start sending in requests for help. Once they've been assigned to a rescuer, we'll see their icon change, and then once they are assigned to or once responders start saying, hey, I'm available and I have a boat that's available for use, you'll see those icons as well. You'll also see here, I think you can see it, I'll move this down just a little bit, but there's like this little triangulation of shelters. So this is where all boats, regardless of where they end up showing up, will end up going to. And this is a live map, so I could add these in any time. I can also create priority zones and say, you know what, if people are in this area, flooding is so bad right there, we really need to focus there first. All responders will be prioritized to this. So again, start thinking in your mind all the things that have to be in place in order for this to happen programmatically. One thing, maybe it'll date me, but something that I was super excited about 10 years ago was before AI, before automation in the maybe new sense, was the concept of business processes, right? Business process management. Anyone remember BPMN and business process notation? It was cool stuff back then. But we actually built business processes to manage each and every incident. It allows us to create isolation, but also be able to scale. And so that's what you'll see as well. All right. So I'm not going to set up any priority zones, but again, when you rebuild this yourself, you're welcome to do that if you'd like. All right, so let's go ahead and start the simulation. There's 50 people, I think, that we're going to try and rescue. And you can see that happening here. You can start to see those little icons showing up. And in a moment, I'll show you the actual back-end work that's happening during this rescue as well. But what I want to do is, notice way up here, right, we have 16 requested, and a bunch of people are like, oh my gosh, I'm in trouble. No one's getting assigned, right? No boats have been identified. So what I'm gonna do right now is just very simply go in and say, I'm gonna add 25 responders to the mix. Oops, don't look. And so as soon as I added those responders, right, which could happen actually dynamically if they let me do the crazy live demo thing, you could register yourself. And when you do that registration, what it asks you for is very simply, do you have a boat? How many people can it serve? And do you have medical supplies? So we could prioritize if people needed medical assistance. Once that happens, you can see as they're assigned, they start to get picked up. And I'll just zoom in a little bit so you can see how this works. Right? And if I go to mission, this allows me to identify my mission. I, Noelle, want to be a rescuer. And so I'm going to identify myself. There I am, a little blue box on East Sahara Ave. Awesome. I'm going to go back to the dashboard and we can now watch me because my icon will be a little bit different than everyone else's. Right? So now as this is going through, we're doing pretty good here, right? We've got 23 people requested, but notice over there also we're able to keep an eye on all of the active respondents. And so these respondents give us the ability to control who's busy and who isn't. Once they go to a shelter, can they immediately be used again? Where's the closest location? This is where my world of artificial intelligence starts to get really exciting. And so I'm going to show you the layered architecture. And the nice thing about building a multi-tiered application with lots of different microservices is that you have the ability to add in small services to help in certain aspects of the application at any time. And on a platform like OpenShift, you get the ability to add that in. And one of my favorite things is I can build my own metrics for success. Inside, using the operator framework, right, inside OpenShift, almost half the room, I think, raised their hand knowing, so hopefully you recognize that term. But it gives us a lot of flexibility of not only, of course, building the infrastructure, adding the applications, but then also controlling the metrics for success in what those applications look like, especially when you start adding in artificial intelligence. If you're not adding in, data analysis, AI, even applied AI models today, you will be very, within the next year to 5 years, you'll definitely be seeing those applied AI models become more and more useful. I mean, SageMaker has been out for a while now, but we're just starting to see organizations really leverage some of these pre-built models and customize them for their use. We're so close to the end now. Everyone's been picked up. They're traveling to their safe destinations. I always, you'll see down here, hopefully, there I am, aw. Now what it's gonna do, so if I waited long enough, it would have been like, there's one person waiting to go to a shelter. I have to acknowledge, according to the business process, that I actually picked up my person. And once I acknowledge them, it then gives me a pathway to the prioritized shelter at that time. So again, based on those circles or the location that I identified, and you can see me traveling my way there now. Right, so let's take a look. I mean, I think we'll come back here if you need to find closure in all of these zeroing out, but we get the idea. There we are, we're there. Yay, they all survived. Good work, you. Okay, so let's go take a look at what this really means. So the first thing I'm gonna do is show you the hybrid cloud console, and some of you may find comfort here and have seen this before. This is OpenShift. One thing I like about this view, of course, is it reminds me about automation. And so you can see I have a ton of automation. Much of what happens in this application is automated through Ansible. So you see that here. I'm gonna actually go into OpenShift and I'll explain to you one of the things I like about this view is that you're gonna see one cluster ER demo, that's the emergency response demo I just showed you. You'll see it's running on ROSA, which is the type, Red Hat OpenShift service on AWS, so that's great. But one thing that I have in some of my customer applications is I see a list here, right? Some are running on ROSA and some are running on other cloud providers or running on premises. So there's lots of options for visibility and being able to control my clusters running in different environments and in different configurations. You can also see the ability to see some shared resources across all your clusters that are organized inside OpenShift. But let's go ahead and take a look at this one specifically. This ER demo has been running for a while. It has, you could see kind of, this is the proof. I tried to show them that I could scale perfectly fine. I'm elastically scaling. I have big old M5 instances. I felt like, anyway, they said no, that's okay. So we're gonna go open up the console and take a look at what this looks like inside of ROSA. So you can see up there in the upper left corner, right? We have the actual, it shows that this is running on AWS. I will, hopefully, open up AWS and show you how to see these things as well. But this is a pretty, this is like the overall dashboard. Let's take a look at some of the things that I personally look for first. I will tell you the number one question I get about ROSA is usually regarding networking. And how do you get something like a cloud provided service, managed service like ROSA, how do you get that running in an environment, maybe even a protected environment? And a networking question becomes very important. So I'll just show you, first of all, how all of those services and applications were deployed. And so you could see those routes here. Each one of these is a URL that you could take to go and check out the application. But more importantly, I'm in the administrator tab right now. So this gives me an administrative view of all of the projects and resources, all the operators that have been installed, everything that's necessary in order to build and run this infrastructure. And of course, it could be multifaceted. I'm running a very large application, or I don't know, a moderately sized application, but it is, it could have, of course, multiple applications that you can see in different topologies. So let me go ahead and show you that next. You could also see the operators that are installed. I'm gonna go ahead and show you that specifically for this project, but there are lots of projects, each project having a different phase, right? So I have a data service layer, I have Apache Kafka, I have, like, there's lots of different pieces within this infrastructure that I'll show you in just a second, and all of them have an application project that is related to them. Okay, so good thing number one, we have an administrator view that gives administrators the ability to implement guardrails around how applications can be deployed in AWS, and a shared environment, a shared view, if you will, with developers. So I moved to the developer view, which is just literally drop down the list, see the developer tab, and it will now generate a view of the topology for me, hopefully. It's big. So this is the topology, and I'm gonna just try and shrink it down for you so you can see. But this is one of the things I love about it, being able to visually see all the pieces in one place, actively running, being able to go into any one of these pods and increase the size if I choose to, change parameters if I choose to, right? Configuration parameters if I want. So you could go in, I remember I did this demo once and I accidentally chose to scale up the pod that had the databases in it. It didn't finish in time for the demo, so I won't be doing that for you today. But it's really neat to be able to just have this view inside of OpenShift, but all of these are EC2 instances running on AWS. So if I can choose how I want to interact with this infrastructure. I also have the ability, and I'll just go in and take a look at one of them. When you click on these resources, it opens up this kind of panel that allows you to see the details. I always go to this detail, and this is how, let's see, what am I looking at? Oh, this is simple application, right? So if I wanted to scale up that application, I just tap a button and poof, it's up and running, right? Again, if you know OpenShift, this may not be like rocket science, life-changing. What is life-changing, at least for my life, is who does this work when things go bad? Or, like in NPR's case, when things are going really well. Who handles the scale? Who handles the issues? Who handles patching, updates? Who handles all of the undifferentiated work of managing this environment? It no longer has to be you. You can focus on the very cool new thing, or on the features on your backlog you're trying to deploy, or on the new DevSecOps stuff that you're trying to get done, or the different, processes that you're trying to develop for your organization. To do the undifferentiated work, like this, right? Being able to increase pod sizes when necessary, or be able to create new boundaries in which a developer or even a data scientist can play. So that is the environment. Now what I want to do is actually talk to you about the application a little bit. You can, if you are one of those people who like to dive a little bit deeper, is you can go out to erdemo.io. And erdemo.io is the documented environment where we put everything about this application. Now, this was actually built for OpenShift dedicated, and it was built originally to run on-prem. But I saw Rosa, and I'm a big fan of AWS. I'm a solutions architect, certified solutions architect. I'm a big fan. And of course, came from the Alexa world. So I was like, how do we move this to AWS? And so I just ported it. And it was a perfect example of, like, I didn't need to really change any code to do that porting. But the good news was I got a different level of visibility, and I didn't have to go through all of the minutia involved in building that infrastructure in AWS alone. So you can go and take a look at it. I'll just briefly show you the architecture so you could see it. But this is something that you could dive deeper on if you choose to, and it's a fun application, pretty detailed, right? So there's several tiers involved. There's the classic application tier that you see there at the top. There is the business tier, right? That's where all of those business process management services are. I'll show you that in just a second. Of course, AMQ. This is a huge messaging app, right? We're talking about people on phones communicating to an app, that's basically talking to a incident console. So AMQ is the heart of a lot of how this communication is happening. And then data, or our services tier. The services tier is actually my favorite. It's where I envisioned adding additional machine learning services, for example, or adding in location services, or adding a little bit more telemetry, SNS, right? For me to be able to maybe send a Starbucks gift card to all of my favorite people who volunteered their services during this emergency, right? Those would be services that you could easily add because of the way the application is architected. So when we started at the beginning with that picture that says container containers don't solve all problems. Like, they solve some problems. Building the little buckets is good. It's an evolution. Thank goodness we got there. But it's everything else, actually, that makes these kinds of projects, these kinds of applications successful. It's the architecture of the application itself. It's the use of, a service mesh that allows all these microservices to communicate to each other. It's the use of database services, right? And the flexibility to use, maybe some of my data is sitting in RDS, maybe some of my data is sitting in a third-party system. I want to be able to create an infrastructure that can see it all. And that's what this environment provides. So let's go back to my obligatory slides. Make sure I cover those too. All right, awesome. So it gives you an idea, and it's meant to just plant the seed. Obviously, in a 45-minute session, or hour, we're not gonna really be able to dive into all the things or get you, oh, I'm sorry, I just hit the laser. Sorry, front row. But one of the things that we did in order to create this, and it kind of reinforces this idea that containers are only one part of it. Like, if you are familiar with Kubernetes, that's awesome. If you use a managed Kubernetes service, great, but that's not how solutions are made, right? It's one piece of a very big puzzle, and most of us in this room, I think, can appreciate that. But this is some of the work that went into building the ER demo process, and it started with Agile, DevOps, right? Like, how do we build this in a way that can scale, that can be broken up into a bunch of different microservices, that can be served in different parts of the infrastructure? I mean, I have a dream of one day having this demo actually sit in a multi-cloud environment, right? We hear every cloud, AWS, multi-cloud, we hear this term, like, take from the best of breed, but how realistic is that really today? Or really, do we even need it or want it? And so I'm always trying to push the envelope of like, well, let's just see it work first. And so that's what we did with this project. One of the other things that we did, of course, and I'm a huge fan of this, so if you are looking to ideate, especially in an environment like Rosa, hackathons are awesome, right? Build a hackathon, an internal hackathon. I created one at NPR. I created one at where was I? Abbey Road. Anyone know it? Maybe. Abbey Road, the Beatles. Okay. But yes, Abbey Road, we did the very first hackathon at Studio One in where the magic music was made. We did it there, but we did it because it wasn't enough just to come in and talk about it. And that's why I love reInvent, but I love the workshops even more. It's not enough to see it. Immediately, you have to have a GitHub repo and you have to be able to apply it. So that's where we did a lot of this work. We even today do weekly Scrum sessions, and we talk about how we evolve this and add additional services. And the way we architected it from the beginning gave us a lot of flexibility. And the most important thing is our little team, we are working kind of pro bono, right, on this project. It's not a funded thing. We're just building it because it's fun. And we don't have to do a lot of the mundane infrastructure administrative work. We can offload that to Rosa. We can let AWS do what it's good at, Red Hat do its OpenShift thing, and then we get to focus on application architecture, service integration, right, on the magic that we provide as technologists. We do it in an open and collaborative way because we're Red Hat, of course. And we made it public. It's open source. As you can see, you can either go to this website, erdemo.io, but there's also a GitHub repo with the same thing. And you'll see as we talk about the future of what's possible with Edge and some of the changes to this architecture as we move into that kind of a world, you'll see we'll also provide you a GitHub repo for that. So these are all the things that are involved in this application. It's meant to demonstrate. So usually in any elaborate demonstration that integrates a bunch of things, we end up using things where we probably could have done it simpler. It's one of the first things I'm like, I didn't really need to do that. I mean, I could have done that in 3 lines of code. But we did things a little bit more complicated in order to make a point, in order to demonstrate a technology was feasible in that use case. So allow that as you're looking through this at a later time. But Prometheus, Grafana, being able to leverage services, the benefit is that there are operators for many of these. So the entire application, when you go to GitHub, you'll notice it's all built with Ansible playbooks. So you want change something, you don't have to change the entire thing. You just go to the Ansible playbook for that piece of the architecture and you modify that or add to that. It gives you so much more flexibility and, of course, visibility inside a platform like Rosa. So this is kind of what the infrastructure looks like. It's like I'm contractually obligated to show you a slide you can barely read from the back, so there it is. But inside of this, you will see, as I mentioned before, it's not just about the operating system and having one that is, enterprise ready and hardened and works really well and everyone's comfortable with it. It's not just about the Kubernetes container architecture that you leverage. It's all the other things. It's everything else you want. It's all the monitoring, the RBAC, anything involved in identity and access management. It's being able to get services to communicate, the ability to deploy those services, to scale those services, all those things that they start to take away from the time you have in a day to actually do the work, to build an app, to create a feature, to deploy a feature. And that's what we want as Red Hat, what we're trying to do, is we want to absolve you of that work so you can focus on what your company is trying to do for the world, right? What do you want to accomplish? What feature do you want to get out there? Let's not spend 45% of your day, which is, documented to be kind of the average, building, setting up, and tearing down the environments that are necessary to support that. Now, we used a lot of cool technology in order to make this possible, and I encourage you to do the same thing, right? As you are investigating and looking at, Rosa is a great place to do this type of investigation, to play around, to innovate, to build hackathons and projects in, because it's managed, right? There's not a whole lot that you have to build manually or integrate manually. But this is just an overlay of some of the technologies that we use, and I'm always looking to expand on the number of boxes that I can have, when I'm trying to think of a new way to accomplish a task. So lots of different community innovation. This goes back to what I mentioned earlier, and this deck will be available as part of the resources in the reInvent package. But business automation is, it's not dead. EJBs, those are dead. But this, not dead, right? Being able to script out and choreograph how users are interacting with your system is still a very valuable, and many, many customers are interested in this ability to choreograph how activities happen within their systems. Today, we're augmenting that with artificial intelligence, right? We are creating opportunities for us to maybe create better predictions on what should happen at different stages of this, but the process itself still needs to be defined, which is a human thing. We do that. It still needs to be monitored, and it still needs to have a level of discernment of whether or not it's serving the ultimate business goal. And that all is human stuff. There's lots of places AI can be used, and I've actually been working on projects that are infusing AI into business processes just like this. But that is the most important thing, is that someone has to define them. Someone has to know what to build, and that is where we come in. Oh, goodness. So this is just a slightly bigger version of the same thing, and really more for your reference. But every activity has, the benefit of microservices and business process automation is the ability to very clearly define the inputs and outputs into each stage of the project, right? And this is not different. This is not Rosa specific, right? This is applications that you build today will run in a Rosa environment. However, when I say that, not every application is, oh goodness, that's not supposed to happen. Not every application is meant to, oh goodness, all right, hold on. We'll just go through. They're supposed to have words on those, so that's not gonna be, AWS edited that out for some reason. So I'll just go back to my pretty picture. But when we're building applications, like the magic isn't, like I said, it isn't in the applications that you're going to deploy. Those are still going to be the same for the most part, right? It's not a huge mental shift to move to Rosa and be like, oh my gosh, what are we going to do for the Rosa environment? It's the same apps. The difference is what you get to do now that many of the tasks involved in deploying to a managed environment are handled by a team like Red Hat's SREs. So I want to walk through a couple of those things, but first talk about the boxes of all of the stuff that we often have to cobble together. So as a DevOps person and really I was the data scientist in the Alexa team that was charged with, and I don't know if any of you know this pain, but we had 419 automated builds. 0 of them were successful for months. Months, like we would go months where we would have 0 of 419 builds succeeded. It's very painful, heartbreaking even. And so what this allows me to do is to create an environment that Noel does not have to do that work anymore, right? I can rely on a code pipeline provided by someone else. I like this visual because it identifies very easily what you no longer have to worry about. This is the beauty of Rosa. This is why if you like OpenShift, you'll love Rosa, because those boxes you used to do that are blue, you no longer have to do now that they're red. Now there are some wonderful boxes we call shared responsibility. Anyone heard this term before in AWS, shared responsibility model? It's a good term, right? It basically means it depends. If you ever used that term before, right? And it does depend quite a bit, but some of those boxes, especially around the hard stuff, security, networking, right? It kind of depends on how much of the best practices you've adopted from AWS, right? How much did you do? Are you well architected? And on top of that, in addition to being, of course, well architected, how much of the best practices and documentation have you accommodated on the Red Hat side? And then some of it you'll just want to own yourself. So we have some organizations that want to own the entire networking environment. They don't want anyone else in there. And so this gives them that capability. So I thought this was an interesting take. And I see a few people like this. They're different now. Right? Like, it's hard. Running Kubernetes in production is hard. It takes the best out of some of us. And so what I try to do is really convey to you, not, again, that it changes your life in what you're going to deploy, but in how you'll deploy it and what time frame you can deploy it in. This is just one view of what this looks like for someone like us who does this work every day, right? If I wasn't using something like OpenShift, and it could be dedicated or on Rosa, right? If I wasn't using something like OpenShift on Rosa, I would have to do all these things, right? I would get the ping, pager duty. There are people with pagers still. Anyone got? No, I won't make you say. But call support, right? All of these things just eat away at the shelf life of really good people in your company. And this is not what they're there to do, right? They're there to do, I remember at NPR, they're there to do pretty cool things. And I remember sitting down in my one-on-ones, I was head of all of the engineers, so I met with all the DevOps and app devs, and I remember them saying, I didn't think I would be doing this thing. That's not what I thought my job would be. I thought I would be doing cool new things. And I don't know any DevOps person or really any human who doesn't feel that way. And so now you know that for some of your workloads, this might be a feasible solution. So as we kind of close out, I want to welcome someone who's going to talk a little bit more about the future and why some of your workloads, like usually I'll go into an organization and figure out, it's kind of like where I was in AWS 15 years ago, right? Hey, what are you doing? What apps fit in this cloud world? What apps now fit in this managed world? And once you figure that out, you're starting to see, right, what apps do you not mind having very little responsibility over that stuff, right? Over managing worker nodes and managing clusters and infrastructure and storage and updates and upgrades, right? Patching, all the undifferentiated heavy lifting that comes with managing a cluster. It's not for every app, but for some of your apps, you might be like, you know what? Maybe I could just put this on Rosa. Let's just get it going. I did this with one customer just a few weeks ago, maybe a month ago now. But before Thanksgiving, where they just wanted to build an app and they didn't want to go through all of the work they had to do with the DevOps and architecture organization to like get it approved. They just wanted it up and running. And they said, well, the infrastructure team loves AWS. Why don't we just tell them to build it on Rosa? They were up in 3 weeks. There was a lot of other stuff that went wrong. Don't get me wrong. But Rosa worked like a charm. But they were able to get up and see real-time information about how the app was working immediately. So the purpose of Rosa is just to be one more tool in your toolbox, right? One more capability that you have to say, I only have so many hours in the day. What apps would work well in a managed environment? What apps can I leverage an SRE team to take care of that minutia as opposed to me dedicating my time and my team's time there? So I wanted to show you a little bit about the private cluster architecture that I used. It is all M5, and I think I created an elastic scaling cluster of minimum 2, maximum of 4, and it works beautifully. Might be a little overkill, but I played a lot with the instances. But the good news is you can play a lot with the instances. You have a lot of choices on instance size to support the workloads that you want to move there. But this is not, like I said, today we talked a little bit about a standard 5-tier application, right? It's got basically, Node.js, a couple Node.js web apps. But this is pretty standard today. It's kind of like a circa 2018 type of app, nothing brand new. But we introduced a concept of integrating with mobile applications, right? We introduced a concept of talking between devices, 5G, edge, but our app doesn't really support any of that natively. So what I wanted to do was invite Verizon to come and talk to you a little bit about the future of what would this architecture look like? How would it change as we move into an edge world? So I want to welcome Robbie Belson to the stage, and he's going to take just about 10 minutes or so and talk to you about the future of OpenShift really anywhere, and this is a good start. I'll go ahead. You here. Oh, you won't need this.
I should be all good. Can you move to the, perfect. Thanks for having me, Noel, and thank you all for coming. I'm super excited here today to tell you a little bit more about how you can extend an OpenShift architecture to quite literally new and cutting-edge ways. And as Noel mentioned, by way of background, my name is Robbie Belson, and I lead our developer relations efforts here at Verizon. So you might think that I'm going to spend the next 10 minutes or so talking about 5G and the integration, and that's part of it. But what you might not know is that Verizon teamed up with AWS to develop a suite of mobile edge computing solutions. We call it Verizon 5G Edge. And at the end of the day, there's basically 2 flavors. You have your public flavor of mobile edge computing, called AWS Wavelength, and then you have a private flavor of mobile edge computing, called AWS Outposts. And the idea here is we wanted to think about, could we extend an OpenShift cluster, one cluster, to all of these different geographies with Outposts and Wavelength? And ultimately, we arrived at the image you see here. But I'm going to tell a story about how we got there. Because we believe that when you bring together OpenShift, AWS Outposts, and AWS Wavelength, you're unlocking new potential for enterprises because you can bring compute topologically closer to end users than you've ever been able to do before. And so to unpack that a little bit further, I always like to start with a problem statement. And in my mind, it's threefold. We saw this brilliant app, this ER demo app. I love it. But my question now is, you have this disaster response use case, real-time decisioning, dispatching, support and operations crews. So the question then becomes, is there a way to bring that compute closer? Because today you saw that cluster was in US East 2 or Ohio, and we're here in Las Vegas. Las Vegas to Ohio is quite a bit of a flight. Even if you go to US West 2, that's almost another 1,000 miles. So is there a way to actually bring that compute closer? That's piece 1. Piece 2, can I do this in such a way, so if this alternative were to exist to bring compute closer in that real-time decisioning, could I do it without inducing undifferentiated heavy lifting, setting up a new networking environment, introducing new AWS concepts I don't understand? Nobody wants that. And then the third piece is, and this is my favorite part, we started to talk about the device fleet. We're starting to see a world, a proliferation of IoT. So there probably will be a world where I may not know my device fleet ahead of time. Said differently, I could have IoT devices within a manufacturing plant connected to a private network, but I could also have mobile devices and tablets and beyond connected to a public network. So that third phase of the problem statement here is, do I have to guess ahead of time what my device fleet will look like, or can I just figure it out later? And so what we're going to show you today is, yes, you can figure it out later. Yes, you can leverage this architecture without undifferentiated heavy lifting. And yes, we can bring compute topologically closer with Wavelength, Outpost, and OpenShift. But for those of you who haven't experienced AWS Wavelength yet, I want to start with a quick primer. So AWS Wavelength, at the end of the day, to best explain it, let's do a quick primer on 5G networks. Say you have a mobile device out and you're consuming an app right now, some sort of mobile app. It's very likely that that application traffic today from your mobile device is going to connect to a 4G or 5G radio. And then from there, all of those radios are going to converge to our mobile packet core. And then from there, at the mobile packet core is precisely where that mobile traffic anchors to an IP address. Why does that matter? That matters because that's how you connect out of the mobile network to then go to, say, US West 2 or US East 2, where your OpenShift cluster lives. But remember that from that journey outside the packet core, all the way to these regions, you have routers that it connects to. And at each of those routers, if that buffer becomes overflown, that could result in unbounded network delays. So wouldn't it be nice to reduce that non-deterministic nature and just bring that compute within the mobile network? That's exactly what AWS Wavelength is. You're taking those core services of AWS, EC2, EBS, and beyond, bringing that within the edge of the mobile network, abstracting away the complexities of the network itself. So if you don't know how 5G networks work, that's OK. You don't have to. And then from there, exposing it in such a way that you don't really have to learn any new concepts. So how do we get to the image on the screen? You're seeing Outpost, Wavelength, all the networking we mentioned. How do you actually get there? 3 basic steps, and I'll show you the example for Wavelength here. You start with a VPC, existing or net new, doesn't matter. And when you create a subnet today, you'll create a subnet corresponding to one of many availability zones, like US East 1A, US East 1F. You're also going to see now, if you click that dropdown, wavelength zones. So even though these wavelength zones are within the Verizon carrier network in 13 cities today, all you have to do is just another subnet. And then the connectivity to the carrier network itself and the internet. Today, traditionally in AWS, you have the internet gateway. In AWS Wavelength, you have the carrier gateway. So very, very familiar concept, same idea. You have a route table, default route through the carrier gateway this time. You attach it to the subnet. So from a networking perspective, it's really just that simple. And I'll add, from an Outpost perspective, it's also very similar. All you have to do, subnet in the Outpost, passing that AWS resource name or ARN of the Outpost. And then from there, it's called a local gateway. You attach a local gateway route table, you're good to go. Point is here, these are you within the AWS console, within a minute of clicking around, you can have a hybrid edge architecture. But now the question is, from a container orchestration perspective, what does that architecture look like? So imagine the following scenario. I'm a manufacturing plant, and I have a series of buildings all across the Northeast, perhaps in Boston, New York City, DC, Atlanta, Miami, et cetera. But then I also have a fleet of perhaps trucks going back and forth, and I'm a supply chain and logistics company, so I want to track those assets in motion. So now we have assets on the move that need the public network, but I also have dedicated assets within these branch offices or manufacturing plants that need the private connectivity. So from a container orchestration perspective, what do? Is this one control plane in each of the outposts, or maybe one control plane or worker nodes everywhere? How do I think about this? The short answer is there are a number of different options, but we'd like to propose one such architecture, and that's what you're seeing on the screen. So what we did, Ansible again for that automation. Everything we're going to showcase today, you can see on Verizon's GitHub. But what we did, API-based installation method, create the control plane, create worker nodes, and then all you have to do is create a machine set in each of these wavelength zones. So in this case, we have a machine set in the New York City wavelength zone. We have a machine set in the Boston wavelength zone. And we also have a machine set corresponding to the outpost that we had in Texas. And the beauty here is, at any point in time, if that number of outposts changes, if I were to add a branch to my manufacturing plant or a new dedicated facility, you can always add a machine set later. So that's piece one. That creates the networking environment and creates the nodes. The question now is, what does it look like from an OpenShift perspective? And that's what you're seeing here in the console. What we found is that Outpost, Wavelength, no matter what edge you're choosing, it's natively supported. And the reason why it's natively supported is because of that abstraction layer that Verizon and AWS have provided through things like the Carrier Gateway. Again, it doesn't really matter to the developer, usually, how the 5G network works. You just want your device to connect. And you want it to look like everything you've been doing in AWS for years. And through things like the Carrier Gateway and wavelength zones just showing up as yet another availability zone, that's exactly how it works. And so if I were to inspect the nodes corresponding to these machine sets, what you'd see under the availability zone ID, you just see the wavelength zone. It's that simple. And so what that means is as you start to think about Industry 4.0 use cases, connecting device fleets across different geographies, that control plane, that only needs to be in one location. And then all of those worker nodes could be truly separated by 1,000 miles. And you might be asking, who cares? Why does this matter? And to me, this matters because it's forcing enterprises to really rethink their decision to move to the edge. It's no longer a yes-no discussion. Rather, it's much more nuanced, much more multifaceted, because you now have almost a limitless permutation of options of what the edge actually means for you. And whether the use case, rather, is smart venues, contactless checkout, autonomous mobile robots, the list goes on, we now have a flexible, scalable, automated, easy-to-use platform to do so. And so the takeaway here is, if you want to learn more, just go try it. What you're seeing here is on Verizon's GitHub, github.com/Verizon/5G Edge tutorials. Let us know what you think. We would love to be your trusted partner in your edge enablement journey. And more broadly, as we think about the combination of AWS Outposts, AWS Wavelength, OpenShift, and Verizon 5G Edge, we believe that this combination together will usher in the next generation of edge-enabled Industry 4.0 applications. And we invite you on that journey with us. Thanks so much, and I'll turn it back over to Noelle.
Thank you. Awesome. I mean, it's just so cool. I just love being able to look at all the different ways. You said it well, permutations, right? Like the thing I want always as either an admin, which my first 10 years of my career was on the sysadmin side, then I moved to the developer side. On both sides, I just wanted choice and security, but I wanted choice. I wanted to be able to have freedom of choice, freedom of technology. I remember the reason I joined Red Hat back in 2008 was because they gave me a pin at an event that was like no vendor lock-in and had like a big red through it, right? And that was the dream, right? The dream was today we call it an open hybrid cloud with cloud native apps. But the reality to me as a dev is I just want to have choice. And I want to be able to do what I want and build the best thing I can build with the best tools available. And of course, accommodate my company's needs at the same time. So of course, before we go, I want to make sure that you guys have an understanding of how you can do this with us, with our help, or you could just go and play around. When I first started, there wasn't a whole lot of people playing around with Rosa community-wise, right? I was looking for YouTube videos, I was looking for anything, and I couldn't find a whole lot. So of course, I started building and creating that kind of content. So you'll see my stuff if you go and Google it. But the other thing is I wanted to find out what happens if you actually do try to install this. The number one question I got before networking about Rosa, when I started to tell people oh my gosh, just go use it. They didn't know if they had to install Rosa or if someone else, like a Magic Fairy, would come and install it for them. And of course, there's both options. Red Hat could be your Magic Fairy. Don't tweet that. But Red Hat could do that work for you, or you could just do it yourself. And so I'll encourage you, most of you seem like practitioners in here, you could just go over to, as a matter of fact, I'm gonna see if it just comes right up in our last few minutes here. We'll see if I'm connected to my good old, no, I'm not. Okay, so I'm not going to show it to you. But one thing that I can do is you could just go into AWS, and in the services, you could just type in Rosa, or you could type the whole long name in, but you could just type in Rosa, it'll come right up. It's a service right on the console. It'll then take you to a couple of steps that you'll have to take, which is, it's all CLI driven. I don't know about you, but I like CLIs, so it worked out for me. I downloaded the CLIs and was able to get my cluster up and running in about 15 minutes. That was for like a Hello World application. This one took a little longer because it's about, I don't know, 700 nodes. So there's a lot more to it. But that's something you could do literally today, and you could deploy a Hello World app, which will provide you, or you can use any of the applications that we give on our GitHub repos. So the last thing I wanted to show you was just a little view into those repos. As Robbie was mentioning, thank you. This is one of those repos. Hopefully, you probably can't see it, but there it is. I'll just make it a little bit bigger so you can see it or take a picture. But Verizon 5G Edge tutorials, you can go and see the OpenShift, the work that was done to kind of test out the edge scenario. You can also see the same thing in the emergency disaster response. If you just go to that demo's homepage, it's right at the bottom. There's a GitHub link there as well. Again, it's just a very simple interface for you to be able to build a relatively elaborate example application and play with it, play around with it. It's the way you learn. We do have a sandbox environment available for this. And we have a couple minutes for questions, so if there's anything that's kind of interesting, or I think we have a mic somewhere that we can have you ask that question so everyone can hear it. We'll stick around for another 5 minutes and answer any questions that you may have. But we'll also be at the welcome reception tonight. So Robbie will be at Verizon, I'll be at Red Hat, as well as our other black belts that support this work. If you need help though, let's say you're not gonna go and build this yourself, you can actually reach out to us as Red Hat, and we have resources dedicated to help you actually build this. They're called black belts. They're super cool. We have one here who can help you get started, and they'll literally sit next to you, fingers on keyboard, and help deploy your first production pilots. So just let me know how we can help you. GitHub repos galore. Enjoy. I hope you enjoyed this session. The last thing I'll ask you to do, I am extremely grateful that you spent this much time with me during your reInvent experience. So thank you for being here. If you would not mind sharing your feedback, I always try to say if you don't have anything nice to say, but no, I won't say that. If you have anything to say about this session, its content or otherwise, please feel free to put that in your survey. They are extremely helpful. They'll help us prioritize events and sessions for next year. So thank you for having us. We'll be here for questions, and have a great reInvent.